So hi everyone. Yeah, that's me. That's Jesús Barraza. And yes, as Sabina was saying, I plan to spend the next kind of 30 minutes or so talking about how graphs can bring value in your digital asset management initiatives. And I'll do that by sharing with you some success stories from our customers. So here's my plan for today's webinar. So I'll start with a brief introduction of what digital asset management is and what are some of its the key capabilities required for a DAM solution. I'll use the term DAM, as you will say, DAM, as digital asset management, and I'll focus on the ones where graphs are especially relevant, of course, and then after that I'll explain why are they relevant and how are they actually being used in these areas, but not from a theoretical point of view. But I'd rather tell you two success stories from two of our customers who have been kind enough to share some very interesting details about their experience. Yeah, I'll conclude with some key takeaways and take questions if we have time. So yes, let's start by trying to define high level what digital asset management is. So it's digital asset management is basically a type of solutions that help organizing, storing, retrieving, finding, and sharing assets in a more general sense. So and we will focus, of course, in rich media assets. So as in graphics, images, audio, rich text, etc. So what do these type of solutions, what type of capabilities do these solutions require? And I'll list them in the next slide. So here's some of the key ones, and I'll highlight in green the ones that are more sort of graphy, or that are more relevant for us today. So the first one, repository and library services. Of course, there's an obvious component in terms of asset manipulation, and by that I mean like basic functions like creation, retrieval, update, deletion, and well, these are essential parts of a digital asset management solution. They will normally take place outside the graph. So Neo4j is not actually the store for the rich media, but rather the index or the registry, if we want to call it like that, containing the information about the assets and the relationships between them. So that takes us to the second capability, which is metadata and taxonomy management. So that's a critical one, and that's one we're going to be exploring a lot more today. And it's essentially the management of the meta information associated with the assets, and we can think here, for example, of areas like annotation or tagging of assets either in a manual or automated way. And sometimes this tagging is done according to domain ontologies, to controlled vocabularies, that can form taxonomies and rich classifications that then enable things like semantic search or recommendations. So that's an area that we'll be exploring today quite a lot. And yeah, of course, then search and navigation is the next one, and these, of course, will significantly benefit from a rich metadata management. Obviously, the next one is lifecycle and rights management, and more specifically the idea of identity and access management. Although I won't go too much into this particular one today, but Neo4j is used very much in that space, and you can find other webinars specifically on that the topic of identity and access management. And finally, production analytics, things like asset usage, search metrics, and things like that. So. Right, and today we'll be looking at two organizations, two companies, for which digital asset managers is at the very core of their business. And I'm talking about the first one is Scripps Networks, which is a media company owning a number of TV channels in the US. And you can imagine that management of video, audio, and these kind of assets will be central to them, right? Second one will be Adobe Behance, and which is an online portfolio website that creatives use to showcase their work for things like self-promotion, of course, and it contains like a kind of a social network around the sharing of this creative work. And again, the management of these rich media is at the center of their business there. So I understand that we are not all purely kind of media organizations, or at least in theory. But if we follow these, I mean, if we trust this quote by Forrester, by the analyst, any company these days is in a way a media company. So the experiences that I'm going to be sharing with you today will be hopefully relevant for you as well, right? So okay, let's move. Before I go into the stories about our customers, the case study, I would take a couple of minutes to refresh on some key characteristics of Neo4j as a graph platform that are going to be crucial, as we're going to see in the success stories, for delivering on key requirements for digital asset management. And these are four that are quite recurrent, so that they tend to appear in most of our projects. And the first one is the need to, I mean, the capacity to capture complexity, right? So these domains are going to be all about capturing relationships between different assets, modeling how they relate to each other, highly connected domains, and we'll see how graphs are a great platform for capturing this kind of complexity. The second one is the flexibility. We're going to see that it's a common topic, the need to evolve quickly and keep competitive, and we see how graphs provide this flexibility and this agility to incorporate new data, to evolve it, to enrich it all the time. Performance, of course, is always there, and in digital asset management it's no exception. So that's another important area, and also the being able to scale is also super relevant. And we're going to see how the graph model and the native graph platform that Neo4j is will be a perfect platform for these sort of needs. So, right, first story, that's Scripps networks, and in particular the project that they call the asset registry. I highlight two areas that are particularly relevant. Is the model flexibility and the expressivity, because we're going to see that these are the aspects that I want to highlight from this story. Right. So bit of context, right? So Scripps is for those of you especially who are outside the US and might not be familiar with them. Now they're part of Discovery Network, but Scripps is a lifestyle media company that owns a number of brands, and especially in television and magazines. And some channels that might be familiar to you are the Food Network, like a DIY network, the Cooking Channel, and some others. So what Scripps wanted to do was to manage their assets consistently, and what I mean by that, let me give you an example of what that means. So let's say we have a video assets that's available on demand for streaming on the website, and well, of course they wanted to know that that's a variant of the show that was broadcast on the last week on the traditional TV, right, on the cable TV. So but they want to go beyond that and be able to, of course, have a single view of this asset, but also want to be able to link it to another asset, which is, for example, in this case, could be, since this is the Food Network, it might be a recipe that's described in this show, right? So a description of the recipe that's presented appears also on the website, and they want to know, for example, that this recipe is a variant of another version of this recipe that appears as a PDF on another source, right? So we see multiple assets here connected to each other, and highly connected domains is the area where graphs kind of excel, of course. But interestingly, they wanted to go and extend this unified view of their assets with by representing real-world entities and things like, for example, they want to model a node in the graph representing the chef, right? Or maybe the host of the show or a guest. But this node will make it possible then to connect to the rest of recipes that are available, for example, for this particular chef, right? So we kind of, if you think of it, we're kind of getting into sort of a knowledge graph territory here, right? We're combining, the digital assets with real world entities like the the chef in this case. And we'll see that this enables, advanced search, semantic search, and opens the door to things like recommendations and personalization. And then there's many more elements that I'm not showing in this initial introduction, things like asset usage, like distribution rights, channels, organizations, to full, rich knowledge graph that they built. Good. So what was required to build this unified view of their assets? So what was required is the integration of multiple DAMs, multiple digital asset management. Because with Scripps, like many organizations, information was fragmented, was spread across multiple systems, and in this case, were multiple digital asset managements. Some were software as a service, some were COTS, some were homegrown. So you could find all sorts of input sources, and what they built with the asset registry is precisely that: is a kind of a single point of access, right, to all the assets, and from the many different DAMs, and kind of a single source of truth, and this in MDM terminology is called a registry style MDM, right, which provides basically an authoritative source, by keeping just the key identifiers of the elements that it integrates, and the relationships between them across all the source systems. And we see in the diagram that we have systems, digital asset management, of course, for video, actually. But there's, of course, there's also things like production deliverables, like closed caption data, still images. There's the documents, like the recipes as well. And what else? We have audio documents, like production management data, and all sorts of information relevant to the management of these assets. But what does the model that they built look like? What's actually in the graph? And they've shared this information, and I'm going to talk a little bit about it. So what we see is it's actually not a model really, because this is instance data, right? So it's like a small fragment of the graph. But let's analyze it looking at the three sections that we've defined there. So section one, if we look at it, that represents the broadcast video, like the traditional sort of cable television that's broadcast at a given time, and what they call the linear scheduling model. And we see the nodes representing shows. Of course, it could be your favorite show here on the Food Network, and shows will have series, right? Or seasons, if you want, which would be the equivalent term, and a series will have episodes, and the episodes will be further broken down in segments, like in video segments. So these are kind of the fragment between two commercials, if you want. So, and we see that there's the use of the part relationship to further divide the elements, right? You see that they're using the same relationship there, and there's an interesting concept there, this idea of an abstract episode, and the reason for that element in the model is that they found that multiple versions of episodes were created over time. Like, for example, there will be an SD and an HD version, but also sometimes what they do is they start to leverage episodes for more purposes. Like, for example, they take 30 seconds out of an episode to move it from one channel to another, from HD TV to DIY, for example, in order to be able to put more advertising, or to be used in other platforms. And what happens is that at the end, well, any given episode will have several versions, right? Which complicated a number of things, like, for example, being able to produce an accurate inventory of episodes. So, for example, to know what can be licensed internationally, or to compute some numbers in terms of utilization of the episodes, because we have like 5 copies of a single one. So what they did is they created this idea of an abstract episode that aggregates, in a way, all the concrete instances of the episode. Good. So let's move on to section 2 in the graph. So here we're looking at video assets that the ones that we're looking at, like in this example, we have, for example, an abstract part that are connected to rich documents. For example, in this case, it's the recipes, right, in the food channel, in the Food Network. So an episode can be related to multiple recipes, right? And that comes from a different DAM, as we saw before. and recipes are linked to instances. So this is actually an actual copy of the document, and that can, for example, these two can represent one PDF version of it and one XML version of it, and they're associated to the location, and that's the physical storage. In this case, it looks like an S3 bucket, right? That's section 2, the related assets. And finally, section 3, we have more assets. In this case, coming from another DAM that it looks like production deliverables, maybe closed caption assets. Again, these are rich documents, and the representation is very similar to the one we just saw for recipes, right? So we see that that we have an instance of an episode that's connected to the number of parts of these closed caption files that are linked themselves to the physical instances and the location in whatever they're stored. So I hope that gives an overview of the way they've modeled their domain. But I'm going to include a section on a very specific problem, expressivity in a way problem. And I mean, it's also a flexibility point of view, because one of the key drivers was the fact that they wanted a platform that would enable the data model to evolve over time, and that's exactly what they meant. So the idea is that, well, Scripps have been for a long time a cable network, a traditional cable network that aired the shows linearly, right? But things are changing these days, and now content is consumed more on demand and through different platforms. So what they have to do is that they have to produce new content, new non-linear content, if you want, that out of existing segments, and these segments are the ones we've described in the previous model. And this is a great case of data composition, right? So you can create a non-linear video asset by combining two segments, and that can go on at many different levels. Then you can combine a number of non-linear video assets into another non-linear video, and so on and so forth. And even to complicate things more, they create this notion of collections, right? A collection is an aggregate, is a list of non-linear video assets. And I mean, let's think here, what would that look like in all the type of data storage, data representation that was not a graph? That's the kind of complexity that would be hard to model and hard to query and hard to maintain. But if I've copied here a fragment, just a tiny bit of Cypher. Cypher is the query language for graphs, and answering a question as simple as list all the non-linear video assets that contain some fragment of a given episode. Well, all you have to do in a graph is identify the asset that represents the episode, and that, in their case, have a unique Scripps ID. And once you identify it, all you have to do is traverse a variable length path following the part relationship and get all the assets that are of type nonlinear video. So very simple, just one line describing a variable length graph pattern that expressed in any other kind of modeling paradigm or modeling representation would be problematic, and as I say, hard to express and maintain. In a graph is kind of a natural thing. So I hope that that's useful, and I'll conclude the story about Scripps by pointing you in the direction of a presentation by Brent Bowman. So they talked about their experience at Groff Connect. I believe it was last year, so you can find it in our YouTube channel. So don't take my word for it and go listen to him. He will tell you how successful they were, and they are in their experience. We have some details about the graph deployment. So it's not a very large one, but here the interest is in how highly connected in the way they explore it. But you can see the kind of throughput that it takes in terms of requests and how flexibility, as I was mentioning before, and this expressivity of the graph was critical to take them down the graph path. Good. So let's move on to the second story, and that's one about Behance. Behance is for those of you who are not familiar with it, is an online platform that showcases and discovers creative work, right? Currently, they have around 10 million members in the platform, and it allows creatives to share the work with hundreds of thousands of daily visitors. And you can think of it as similar to Twitter, but for creative work. So basically, other members of Behance can follow your profile, and you can in turn follow other members. So when you follow someone, their updates, and that can be projects that they upload, or projects that they appreciate, that they like, or collections that they create, they will appear in your activity feed. So this is actually the specific project that they used graphs for. So this activity feed, that was in a way a way to socialize and to search and explore the rich media that they manage. And here the key is performance and efficiency, as we're going to see. So here's what the activity feed looks like. So it's sort of the home screen when a member signs into Behance, right? And you can see here that it has the typical, that's the activity from the creatives you follow. So you follow a number of people, and you see what people has liked, people have commented, what people have appreciated. And of course, the more profiles you follow, well, you see more and more projects appearing in your feed. And what was the problem? What did it all start? And the pain point was kind of known from the very beginning. So they basically wanted to or I would say needed to lower the cost of their existing. So it was not a greenfield. I mean, that they initially implemented an activity feed using Cassandra column store as their backend, but they realized that they needed to lower the cost of running this feature. And if we double click on this idea of lowering the cost, what it means is that they wanted to move towards a more efficient and robust solution that would reduce or ideally minimize the routine maintenance. And they wanted to also reduce the size and the complexity of the existing deployment, which was rather large, as we're going to see in a minute, and was an important cost for the ops team that, as we're going to see in a minute. So, but at the same time, they didn't want to lose. They wanted to maintain, of course, all the user-facing feature set. And they wanted no degradation on the performance of the activity feed, and also keeping in mind extensibility. As you see, this is a recurring point. So being able to add new features and stay competitive and stay attractive for users is a common topic for all our projects. But I was saying that the problem was in this fan out model. Let me elaborate a little bit on these. And I've stolen these three slides from the presentation when they actually published this initial approach in Cassandra. The fan-out model, it was, as I was saying, at the root of the other pain, right? So what happens, the way Cassandra basically tackled the activity feed, is that when an individual publishes a new project, right, or appreciate or does any kind of action in the platform, these had to be written to the timeline, to the feed of every single follower that they had. So basically, if I publish something, that's absolutely fine because I'm followed by 3 people, so that should be a rather small transaction. But if a popular artist that's followed by, let's say, 100,000 people publishes something, that becomes a rather chunky piece of work because it involves 100,000 writes, and this creates first of all a huge data set. You can see that the data set was around 50 terabytes, but also a rather large deployment of a cluster of 48 nodes, and the process of broadcasting an action could take up to 15 minutes in the cases that I was mentioning, like very popular with many followers, used with many followers. So and Of course, there were many feed actions, as you can imagine, in a community with 10 million members. That was, as I was saying, the old days. But now they've managed to get rid of the fan out problem. This having to broadcast and do a massive amount of writes every time there's an update by introducing graphs. And now they're using Neo as the backend for the activity feed. And the thing is, Neo4j is a graph database, so it allows to completely change the paradigm, right? So in a graph, you don't need to broadcast every action to all the followers, and you can basically move from a push approach where you have to push and broadcast all changes to a pull approach. So all we have to do is keep a member's timeline up to date, right? And this is basically means writing only once, and then have all the followers pulling the updates when they need their activity feed populated or refreshed. So here's in the diagram, you can see what that looks like. It's a very simple model. So you have users that follow users, and a user will have a number of actions, like publishing action, appreciate an action, to projects that might be audio, video, photos, etc. And things like getting the last updates by the users you follow can be expressed in a simple query like the one you're seeing there. So you identify a user by ID, you find who he or she follows, and for these users, you get everything that has been published. Of course, you would define a time range, but that's basically the query that you need to run, and that's something that you can do on the fly in a graph database. So now, for those of you who are more into data modeling, you will ask yourself how does that perform at scale, right? What happens when, for example, you have tens of thousands of followers? Because then, of course, that's think of that creates from a graph data modeling point of view a very dense nodes, and we know that this can be a bit problematic, but we have ways to work around that, and let's talk a little bit about it. So again, I like to steal slides from people, and this is the presentation that that the Behance team presented at Groff Connect as well. And one of the techniques they use for boosting the performance, the rate performance of these dense nodes, is this idea of tiered relationships. So a user will have a link to to a project representing every single action, and that can be appreciating a project, commenting on a project. And rather than having to scan all the recent actions, which will be scanning a large number of relationships, what they did is they kept a relationship aggregating the 400 recent actions, the 200 recent actions, and that reduces, of course, the search space and makes it possible to run very, very fast queries, even for super dense nodes, and that retrieve the most recent actions to populate very quickly the activity feed of the followers, right? That's the kind of query that they were using. That's not the only approach, right? This is David Fox's slide. I'll refer you to him in a minute. He's the team lead at Adobe that presented at Groff Connect. So another approach, if you need to be more granular, for example, and be able to query time ranges, is the one described by my colleague Max DeMarcy. You have the URL of his blog there. So and what he does is you can encode in the relationship information about the time range, right? And that, again, the whole idea is to reduce the search space by using specific, I call them qualified relationships, because they encode in the type the time range. In this case, he's doing it at the day level, but that could be at the week level, at the month level. It's your decision, and still get the performance that you expect from for a fast read, even on a super dense node. And there's a couple of blog posts, as I was mentioning, one about news feeds, and another one where he takes you all the way through the process of building a kind of a Twitter sort of clone, a Twitter kind of application. So yeah, back to the Behance use case. So some numbers on what it means, what the change meant in terms of performance and user experience. So what we're evaluating here is the process, the onboarding process. So when you log into, when you sign up for Behance for the first time, you will be asked to select a number of topics, areas that you're interested in, like photography, illustration, etc. And your custom feed will be created, and that takes some time. And in the previous approach that involved the whole broadcasting and writing with the fan out problem, they were seeing that depending on the number of categories you selected, you would have to wait, and that's the time you would spend in this page before your feed is populated. And we see that there was an immediate improvement in the performance, in the experience of this initial creation of your custom feed, right? So especially when you select a large number of categories, in this case, I think the total was 13 at the time. We see that in the old approach involving a column store, they went up to 4 seconds, whereas in the graph we stayed sub-second. So right, and more importantly, the new approach was significantly more efficient, and David highlights that again. I refer you to the recording to hear it directly from him. And the cost of maintaining a cluster of 48 nodes is nothing compared to a very lightweight cluster of 3 nodes, which is what they have with Neo4j now. And look at the data set, the size of the data set. Of course, the previous one had a huge amount of replication every time an action was propagated and broadcast to all the followers. Now we have a very, very compact database that's orders of magnitude. You can see around 1,000 times smaller. And of course, that's a reduction in cost, which is exactly what they were facing. But what's interesting is they've, of course, improved, even in the presence of this reduction in cost, they've improved the user-facing experience. And there's now things like immediate reflection on the, sorry, you see immediately in your feed the effect of, for example, unfollowing a user. Think of what would unfollow mean in the previous approach and in the graph approach. I mean, unfollow someone who's already posted and broadcast loads of updates becomes a cost and an expensive operation. Whereas in a graph, all you have to do is go back to this diagram, is break this connection, this following connection, and the next time you request all the updates from the people you follow, you will just not get it. It's as simple as that. So immediate visualization of the results of an unfollow operation. Good. So again, go and listen to David's presentation, which is probably a lot better than just listening to me. So yeah, I'm conscious of time, so let's go with some key takeaways. So we've seen in the 2 stories that Neo4j is a great platform to build asset or enrich asset management solutions, right? Because it brings the the required flexibility, the expressiveness, to capture these highly connected and complex domains, right? And so yeah, in that sense, Graph gives you a head start in David Fox from Behance insists in his talk how Neo4j enables rapid prototyping, and that significantly reduces things, go-to-market, which is something that always appealing for management, right? Because very little resources are required for that. And also worth mentioning that Neo4j comes with a library of graph algorithms that put you on track, not just to solve the problem at hand, but also put you on track for more advanced uses, like for digital assets, like recommendations, personalizations, etc. So where do we go next from here? So of course, if you haven't done it yet, go to neo4j.com and download the Graph platform. Of course, as I said before, watch and read all the resources that I mentioned in this webinar, and I believe Sabina will be sending you all the details. So yeah, don't take my word for it and listen it directly from them. Go to Max's blog, because there's lots of super interesting information, more on the technical side. I would say, now that I think of it, I should have added Albelly to the list. Albelly is an online photo product company in Europe that provides services like printing, like creation of personalized photo products, like cards, like albums. And again, managing for them, managing the users' photo collection is another great story on digital asset management. So maybe we'll talk about that in another webinar. But yeah, access to all these resources in the different Neo4j channels, and yes, join our online community, because that's where you will learn from other people, and where you will be able to share your experience, and there you have the link. And then if you're further down in the process and you're ready, then reach out to us for licensing information and for best practices to build your DAM solutions with Neo4j. So yeah, that's it for me today.